Today I will show you an example of a force and how to find out the components of this force. So it's simple like at the resolution of a vector. So I am here considering a force of 2 Newton at the object which makes an angle 30 degrees with the x-axis. So I draw a diagram as shown here. So let me find out the components of this vector f, which is 2 Newton, and its direction is 30 degree. It makes angle 30 degree with the x-axis. So if I resolve this vector, this will be my x components. I will denote the x component by with f of x, and this would be the y component. So I will denote this vector with f of y. Make sure always the resultant vectors should be in the between these components. So you need to consider in the direction, or you can this take as the y components, because this and these are the parallel lines to y-axis. So you can take any one, it does not matter. So as I told in my last video, the x component is associated with the x with the cos, which gives me this is 2 Newton times cos 30. Value is square root 3 divided by 2. So this is square root 3 Newton. This is the x component, and similarly I can find the y components. F sine 30 will give the y component. So this and sine 30 is just 1 by 2. So this is 1 Newton. Now I have 1 Newton along y direction. The force of 1 Newton acts along y direction, and the force of square root 3 Newton acts along the x-axis. So in this way we can find the component of the force, or if you want, if you have a component, you can find the total force. Just I will show you how to find the total force if you have a component. So I suppose I have now I will suppose I have components fx and f. I have components fx. Let us suppose now it's the components are given. Fx, x component is root 3 Newton, and the y component is just 1 Newton. Now I need to find the total force and its direction. So the total force is always the square of the x component plus the square of the y component. So I'm talking about the just only magnitude. So it's square root of 3 squared plus 1 square. So this will give me 3 plus 1, and 3 plus 1 4, and this is square root is 2. So 2 Newton. We get the actual force. If we can go back from component to resultant force, or resultant force to the components. So now I need to find out the angle. Suppose this force makes an angle theta with the x-axis, then the tan theta is, now we know we have this one, y and x. So tan theta, if this angle is supposed to be theta, then this should be tan theta, this should be equal to, in this triangle, fy divided by fx. So tan theta is fy divided by fx. And if you replace the values, fy is root 1, sorry, it's 1, and 1 divided by root 3. And if you take slightly, if you want to calculate an in this angle, then you need to take inverse or arctan. This will give me the 30 degrees. So angle is 30 degree. So this will show that the true Newton force is acting at the angle 30 degree with the x-axis. So we can go, I mean we can go back to the original force from its resultant, as well as we can find out the component from the main force. So now I will show you the another example to calculate the components. Suppose I will draw my axis like this, both in the direction of negative and in the, oh, it's not good. Let me, okay, I will draw my axis from here, and okay, this is my x, and this is minus x, this is y, and this is minus y. Now suppose a vector acting at the angle this direction. So this is my vector now. So if you given this angle, now suppose this angle is 45. So I will give you some hints that is useful. Always try take an angle made with the positive x-axis. So always try to take this angle will be the 135. Otherwise you need to take care of signs. So you can do in two way. Either you need to take care of this angle made with positive, or just suppose, or you need to take care of the signs. So let me resolve this one, that will make you more clear. So if I resolve this one is the x component of this vector. Suppose the same of vector of 2 Newton. So this is the components along the x-axis, and you can write this as, or this as, the y components. It's fine. So now you can write in two ways. So fx, I again consider it's 2 Newton times, so this one is cos 2 Newton times cos 45 degree. Always remember that this is in negative x-axis, so you need to consider this one is negative, because this x component is in negative x-axis. That's why you need to consider this one is negative. And the y component is still in positive, so 2 Newton sine 45. Yeah, you can you can always do like this. You need to take care of the signs, whether the component is going in positive x-axis or negative x-axis, or it's going on positive y or negative y. This is one way. But the another way, if you consider angle made with the positive x-axis, then you do not need to take care of this negative sign. So if I consider this 135 is my angle, then you need simply fx is 2 Newton cos 180 minus 45. Yeah, 180 minus 45. So this is angle 180 minus 45, that is 135. And the fy is also 2 Newton sine 180 minus 45. So this will give you the same one. 180 cos 180 minus 45 is a minus, so a minus sign will came from here, and this will give you the same thing. So you need to consider whether you are considering the angle made with x-axis, positive x-axis. So positive x-axis, be careful on that, the angle made with positive x-axis or always with this one, positive x-axis. If you consider angle made with positive x-axis, then you do not need to take care of signs of the component, but if you just take the angle, then you need to take care of the sign of components. So let me show you another example of this one that might be helpful. Let me again draw my axis. So this is again as it is, this is x positive, this is negative, this is positive, this is negative. Now if you have a vector that have an that vector f, this is vector f which makes an angle, so you need to take care of which angle you are now trying. This is the angle, suppose it's 30. Now the both component of vector will be this one also, the x component it should be a negative, and the y component also should be a negative. So here you get both component negative, so you need to take care. If you consider this angle 30, if you consider this whole angle, this is up to here 180 and up to here 30, so this angle is 180 plus 30. If you take 180 plus 30, you do not need to take care of the signs of the components. Yeah, that will automatically give you both minus signs. So I recommend you use any one method, but be careful on the signs.